So looking at some further problems on the geometrical applications of calculus and our stationary points. So we've got this function here, x squared minus 6x plus 5. How do we find what type of turning points we do, or stationary points we do have? We get our first derivative. We set it equal to 0 because we know we've got a horizontal tangent at x is equal to 0. So that's where the curve's stationary. So solving that gives us x is equal to 3, so our y value must be minus 4. And then we test. We test before 3 and after 3, and we get a gradient that's negative and 0 and positive, which means the curve must be a minimum turning point, because that's what a minimum turning point has: a negative gradient, 0, and then it rises, has a positive gradient, so it rises. This one we got 4x squared minus 9x plus 5. Again, derive, find the value of x when it's equal to 0, and then find your y value. Test before 9 on 8 and after 9 on 8, so pick some nice values. So you could pick 1 there, you could pick 2, and that will give you the gradient at those different points, because there's no other turning points, stationary points there. So we get a gradient that's falling at 0 and then it's rising, so it's a minimum turning point. So question 3 here, again, another easy parabola. So differentiate, solve to get x is equal to 7 on 2. We get our value of minus a quarter for y. So that's where it's going to turn. And it's a minimum turning point because we can test before and after, get a negative gradient, 0 gradient, and then a positive gradient. So it's a minimum turning point. This time with a cubic, so we differentiate, we get 6x squared minus 6 is equal to 0. So 6x squared is equal to 6, so x squared is equal to 1. And then we just solve to give it x is equal to plus or minus 1. We get our y values, and we're testing as well then. So we've got minus 1 and 1 gives us a gradient of 0, so we know our curve's stationary there. Before minus 1 we test, we get a positive gradient. At 0 we get a negative gradient, so we're just subbing those values in. Getting a negative gradient, trying 2, which is after 1, getting a positive gradient. So our curve rises is stationary, falls is stationary, and then rises. So we know what our shape of our curve should look like. It's just a case of getting our points correctly on a graph and then making sure our graph turns accordingly. So that's how we start to graph those up and get our graphs of our turning points and the graph of the function using calculus.